Thank you, Mr. Anil Kumar Tiwari, for giving me an introduction to your all these active staff of this great company. And I am also very happy and proud to be associated with you. And today, uh, I'm here in my Oslo University Hospital office. Now it is almost 3:15 time here, and we are completely covered by white snow. It's a white Christmas this year, and temperature is between -7 to -15. And I'm here, and I'll be very happy to share with this journey. And also, I will tell why it is so important, especially for India. And second thing is that how we come up to here. And for that, it's in the big journey. It is just not a story in the society. Science actually believes in result and also experimental evidence from the lab to the bench and to the bed, actually. Then it is science. Something you can see in an isolated way in the laboratory, but in whole body physiology, it may not have any impact. Also, it can happen also vice versa. So today I will be sharing a story that is called now Hearty, how it was developed and what is the mechanism behind it and what sort of experimental evidence we have. And most importantly, the human trials, that is the most important thing. And that tell us its importance and it is workable and it is working in human in vivo system. So without much ado, I will just share my screen so that all you can see my slides. For that, I will, yeah. Just a minute. Where is the Zoom? Oh, here. Can you see the slides now? Hello?
Yes, sir. Yes, sir.
Okay, I can make it a little bit bigger.
Yeah.
Yeah, is okay?
Yes, sir.
Yeah, okay. So here I am. The title is Taking Kiwifruit to the Heart. And after my lecture, you have plenty of time to talk about and ask questions about the kiwifruit and its product. But I will not be entertaining you on any personal clinical situation apart from heart disease, etc., because I think then we should meet differently. But it is only for Hearty today. And this is the hospital. This is a Norwegian, the national hospital. In Norway, the health system is free. Anybody can come and having a treatment without paying a single penny. And that is a social medicine. So that's why the most important academic for medical students part is that that every citizen of this country, they should have a good living condition, they should understand the health, physiology, etc., so that they don't need to go to depend on the medicine. Because every medicine has side effect, as you know, and the list grows on. And that means our body is quite saturated with different chemicals, and we are destroying not only our body, the environment, the water system, etc., etc. So there must be some end to it. Otherwise, it's a big problem coming. Because our body itself, our own cells and the bacteria, that is very important in our system, especially in the gut. If they get wrong type of chemicals, all the time chemicals, we damage our gut system. You'll find wind, etc., sleepless, etc. So it's a big problem. And being a medical person today, we are more working all the time. How can we avoid the medicine? Our forefather of medicine, or you can say father of medicine, he said, the Sir John Osler, that the primary duty of the medical doctor is to advise the people not to take the medicine. So today, with this knowledge that you will have later, that you will find that what we can do about it, especially the impact of cardiovascular problems in India. if you read the news or listen to the news, you would find that invariably there are a lot of people are dying or having a heart attack or stroke because of cardiovascular problems, and ultimately they end up in a hospital. Either they have to go for huge changes of lifestyle, or they have to put a stent so that blood can flow, try to manage the coronary arterial system. I'll talk later on. Or they have to go to the bypass. But this is not the end of the story, because what we're talking today, that the cardiovascular drain system that we have, that the blood is flowing from the heart to the different tissues, including brain, organs, and also taking it back to our heart. Then we get rid of carbon dioxide, etc., getting oxygen again, and some of them eliminated in the kidney. So this is very important, this cardiovascular system, the drain work, that we have actually 60 miles of cardiovascular network where the blood is flowing all the time throughout the body, nourishing our cells, and our brain is all the time needs energy and oxygen, etc. Otherwise, we'll be in a big problem, including other tissue, etc. So it's very important, the blood. Without blood, as you know, we cannot survive. So what is in the blood? Why blood is so important? What is the main duty? I will not go too much detail into that, just to tell you that we have 5 liters of blood, and this blood contains so many types of cells we call blood cells. Red blood cells, which have hemoglobin. It carries oxygen to the tissues. That's where we survive, because oxygen is required for burning carbohydrate, that we get the energy, so the muscle can work, brain can think, and that's why I'm moving my hand here and there because of that. And it has also iron that carries the oxygen, etc. And it has also a lot of white blood cells, different types. They are the military person. They are working against the invasion of any pathogen, or if our cells go astray, then it has a kind of it lead to cancer, etc., that can be killed by some of the immune cells, so that we don't have these cancers. I'll go details into that later, but it's not important. But it's very important that if we get infected, these cells are increased so that they can fight a lot. And then platelet. This is very important. That we'll be talking today. Platelet is involved in cardiac system. Its main job is it doesn't allow any bleeding outside our body, so it tries to seal the vessel wall. That is its main job. So that in sealing that, it then repair the vessel system. If we cut or any injury in our vein or anything, vein is on the surface, so the chance of cutting vein is much more than artery. Artery is much deeper, which take the oxygenated blood to different tissues. And this vein actually that carries back to the heart, and then to the lung, then we get oxygen again, then goes on. So I will be talking about the mostly platelet. And also blood has several proteins, nutrients, and iron, etc., to make sure that the blood goes with the osmotically more competent, so that the tube doesn't collapse. It maintains the pressure, and we have to maintain 120/80 as we measure, so the blood can flow and we can survive as long as, with the proper blood flow. So this is very important. Now, why platelets are there in our body? And oh God, somebody's calling. Sorry. And why platelet is important? Without platelet, we cannot survive for a minute. If the vessel is broken, when we cut accidentally ourselves or anything, the platelet is the first army. They will come to that site and make a seal so that blood cannot come out. If blood comes out, then the blood pressure will be down. We have only 5 liter bloods, then the pressure will be low and we will die. So this is very important. So nature produced in such a way that platelet can be aggregated anytime by 3-4 different agents. And this is very important when it is needed. But if it happens when you don't need it, as it happened cardiac attack or in the stroke, then we have a problem. So the way the platelet aggregates, when we cut ourselves blood vessel injury, as you see here, and then it sends a neural signal, so the blood vessel is constricted, so that the blood doesn't come out. That is the first response. Then the coagulation become active. The proteins are there, soluble. They become aggregated and produce clot. And the most important is platelet aggregation. And this aggregated platelet and clot of the blood coagulation, they come together. They make a stable hemostatic plug. Hemostatic plug, it means hemo means blood, and the statics is blood. Blood is now the cell is completely formed and is stable. And once the tissue is repaired, the vessel is repaired, then it will be sloughed off, it will be dissolved. That is called hemostasis. So the main job of platelet is to see, is there any bleeding there? And they will come to that side and make a plug so that blood doesn't come out. And then once the vessel is repaired, then it will go away. But the platelet name is thrombocyte, sorry. And that's why we call thrombosis. When it happens, they used to call thrombosis because everybody know even that time, 100 years back, the platelet is the major creator of this disease or the final player of the disease. But still, even today, as I speak to you, we don't know all the risk factor of cardiovascular disease. Oh God, this guy is something. This, what I'm saying, okay. As I speak today, the cardiac problem, we don't know why it is happening. But as you look at the epidemiology now in India, cardiac disease is the #1 killer because for a lot of reasons that I'll come later on, and we don't know how to stop it. We only take care of the people when they come to the hospital, they get the treatment, either medicine or drug or surgical. Surgical means it could be stent, it could be bypass, but the medicine, there are certain medicine you can restrain cardiovascular events by lowering the blood pressure, by lowering the blood cholesterol, and also a lot of diabetic people also end up in a cardiac disease because they hyperglycemia that actually changes the blood vessel, increase the blood pressure, so ultimately leads to cardiac disease. But still, as I said, the age is one of the not problem. I think when people get old, their vascular system get wrinkled. It is not that expandable anymore, so that
recording stopped.
Platelet is activated, and then we have a male or female, but today we know it doesn't matter. Both male and female, they are also victim of cardiovascular disease, and the family history is important. Some family are prone to cardiovascular disease because of the genetic problem, etc.
Recording in progress.
They have this problem, and high blood pressure, high cholesterol, diabetes, etc. are known that can increase the probability of having a cardiovascular disease. But still, we don't know 50% why the young people are dying in India, why the athletes are having a cardiac arrest, why when people work hard, all of a sudden having these problems, we have no idea. As I go along, you will have some idea why or some clue how we can solve these problems. So this is the scenario. But if you look at the different factors involved in heart disease, some are modifiable and some are not modifiable. The green things, the green circles, these are modifiable, the lifestyle problem mostly, also other problem, but the the blue circles, you cannot do anything. Genetic factor, race, ethnicity, getting old, you cannot change much. Gender, it is not true anymore. Male and female both has a similar propensity to develop cardiovascular disease. But come to this side, right side, the smoking, is it known? The smoking not only in cardiovascular disease, cancer, etc. But there are some exceptions. Some people, even with smoking, does not develop. But it is not the science. Exception is exception. Everywhere there is some exception. But smoking is injurious to health, and it increases the platelet hyperactivity, cardiovascular problem, other things, and it should be stopped. Diabetes, if somebody has diabetes, his blood flow will be different, his platelet will be active, his blood coagulation will be more thrombotic way, more proactive, and that can lead to cardiovascular disease. But you can change the diabetic status of the body, then of course you can change the propensity of development of cardiovascular disease. Then the physical activity. If we sit all the time, doesn't matter your age, you could be very young, you could be very old, and you could be middle-aged, physically active, but it's very important, the physical activity. And physical activity is a part of our physiology, because from our time of Paleolithic time, our ancestors, they used to move a lot to get the food, and those who could not do, they die down. So we inherit the physiology as well as the genotypes that involve the physical activity. And that time, food used to come on. Our ancestor used to go for hunting to take the food, and still it was not enough. There was a famine and feast cycle was there, so we had to survive. So that's why the physical activity was so important, and it is related with food and health. But at that time, those who could not do it, they died down. But one interesting thing, that physical activity, the food and physical activity, at that time, we developed a system that if we get excess food, we store it for rainy day. That is obesity. We call it today obesity. But at that time, it was important. It saved us from the famine and etc. Then we use the stored energy that is stored in terms of obesity or mental lipid, etc., for our survival. But today it become liability. We call obesity is a disease. 60% of the obese people will develop cardiovascular disease, diabetes, and also cancer. So obesity is now it is a liability because food is coming on our table. We have extra energy, we save it, and especially Indian, we save near the tummy. The Western people save their energy in the thigh. So that is the apple-shaped obesity. We have a kind of we have a apple-shaped obesity. They have a pear-shaped shape of obesity, and they have a different implications in cardiovascular disease and platelet activity. And second thing is high cholesterol. That study came from the pathological studies. Those people who died for cardiovascular disease, then they did the pathological test. They found most of the clot, or plaque, that is actually narrowed the artery or blocked the artery. They contain a lot of cholesterol and calcium. That's why we stopped. We thought the high cholesterol could be the kind of giving the all the necessary ingredients to build up the atherosclerotic plaque. But this is not true much. I will come to the next slide on that. And also high blood pressure. High blood pressure is a big problem in India because, again, of high glucose, insulin resistance, pollution, stress, etc. We cannot maintain the normal blood pressure. 120 by 80, even 115 by 70 is very good. And everybody, not everybody, a lot of people have a high blood pressure, and they don't care because it's mostly asymptomatic. You have no way to know unless you measure the blood pressure. But measuring blood pressure has something plot is called white syndrome. If you are very sensitive, you should not measure yourself very often. That can give the wrong kind of high blood pressure. Anyhow, these are the things we can work on it and can reduce the propensity of the cardiovascular disease. But if you see that cholesterol itself is not the risk factor, it depends on the geography. society, food habit, etc. If you look at this slide, the yellow one is no myocardial infection, and the yellow one, or gerua, whatever you call it, myocardial infection. And we don't see any difference. So the total serum cholesterol, the percents of population with this kind of disease, there is no change. There is no 80% of the people who have a coronary arterial disease, CAD, have the same blood cholesterol than those who didn't have. That means cholesterol may be risk factor for some people, not for everyone. And if you look at the people lives in Mediterranean place, they have used a lot of olive oil, tomato, red wine, etc. They are quite protected from cardiovascular disease. Even they have a high cholesterol and smokes. But it is, you cannot do it in India and also in America. We are more sensitive to cholesterol. Now, we are talking about all this so far. The different factors that is contributing to cardiovascular disease. And also, if we modify certain of this, you can reduce the change of cardiovascular disease. But this is not the end of the story. Because if you look at any patient today in India, they take anti-hypertensive drugs, they take lowering blood pressure, lowering cholesterol drugs, and also they get other things, including some people get antiplatelet drugs, those who have a cardiovascular problem already. In addition, they take something called, against the wind, the gas formation. It is there. Because you are taking all multiple medicine, etc. We are damaging our gut. And damaging gut means you are damaging the microflora, the bacteria. Those are maintaining ourselves. We have more bacteria ourselves than our own body cell. And in gut, we have 2 kilograms weight of bacteria that is helping us all the time. And they are in a trouble because we are getting a lot of medicine. They are destroying this microflora, and it is occupied by other kind of bacteria from the environment, and they produce so many nasty molecules. I'll come to the later on, involving cardiovascular attack. Plus also they are not protecting the gut. So we have a kind of ulcer, we have a wound formation, blotted things, etc., etc. Anyhow, so at that time in 1990, I just joined Aberdeen University. I was a hematologist. I work on platelet in America. So obviously, at that time, the people are working on antioxidant, etc., cholesterol, etc., etc. So I thought I should be doing something different. And also at that time, we know only the platelet is involved in the final events of the cardiovascular process, that is heart attack. You have to take antiplatelet drug, so platelet does not aggregate and can save you from big things. And also in the stroke, something. But what is the factor, or what are the factors that is responsible for plaque formation? Because you have a 62,000 miles of drain system where the blood goes and come back, arterial and the vein system, and bring everything to the heart, or taking away from the heart after oxygenation to where we take the oxygen. But if this circulation system in the heart is very important, if it is get narrowed or blocked, then heart does not get the energy. And if heart doesn't get the energy, the tissue will die. We call myocardial infarction, and they will try to pump all the time because this is autonomic system almost, and that's create a big problem. So how can we really work on that so that our drain system, especially in the body, most importantly in the cardiovascular system, in the heart, it gets protected? Of course, we know if you take saturated fat, red meat, etc., that contribute to the plaque formation in the heart. But it is not the end of the story. It doesn't happen to everybody, as I mentioned in a Greek population and others. So there must be something mechanism we don't know, and we must know it, and then we can find out the preventive method about it. But we know the platelet is involved in cardiac event, and now I added the maintenance of atherosclerosis or the patency of the vascular system. So the platelet is important because at that time it is present in the plaque. Because when people died, we did called pathological test, and then we found in the tissue there are a lot of platelet, cholesterol, calcium, etc. there, and also those people are smoking, having cancer, obesity, high-fat diet. They have a hyperactive platelet. So there is a hyperactive platelet in the circulation that we still measure it here. And then it is also known, as I mentioned, that any heart patient, whether have a stent or have a bypass surgery, they must have antiplatelet drugs. And aspirin is one of the most gold standard drug even today. But 30% people don't respond at all. I'll come later on that. And so that means platelet is important in the CVD, penultimate disease, as well as could be in atherosclerotic plaque formation. But aspirin has a lot of side effects. As you know, it destroys the gut and 30% doesn't respond at all. Anybody, any race, 30% of the people, they don't respond to the aspirin. And it has a side effect. And if somebody is 100% responsive, he has to wait 10 days to go for the surgery because platelet become already inactive. So they cannot do any surgery if the people take aspirin. So let's talk about the blood vessel, how the atherosclerotic plaque is produced. As I mentioned, we have a 60,000-mile network of blood flow in our body, brain, whole systems, skin, everywhere. All the organ, they need blood. Without blood, we cannot survive. Because the important thing of the blood, they take the different cells. If there is inflammation, they will work on it. If the pathogen attack, they will work on it. And they also give energy. They give ions. They give oxygens, everything. Carbohydrate, fat, glucose, they give fatty acid. That is their job. It's like a river. And also they bring back. This is these two artery and vein, they mix, the meat here is called it capillary, or there the exchange happens. The blue thing means because we made it blue, because it does not have a oxygen, it is always spent, so that they are getting from the tissue. Once the metabolism is there, then they are exchanging with the blood, with oxygen, with from the arterial situation. This thing happened. So our job is to keep the drain system very clean and very competent, so that no kind of any kind of what I call precipitation or the cellular debris or anything they should touch, or they should be clean to this surface, inner surface of this drain system. But there are trillions of cells moving under different conditions. The way we are moving, we are doing bending, we are working, all these things, they have to be there. And these a trillion cells that has, as I mentioned, red blood cells, white blood cell, plasma proteins, iron, vitamins, fatty acid, carbohydrate, amino acid, etc. Everything are there along with the platelet also there. Though this is the situation with the arterial and vein systems. And this is the trillions of cells are moving directions that way. So we have to make sure that this drain system has to be very good, refractile, and it does not attach to the cells, so a cell can go smoothly. We call good blood flow. But the platelet, I come to the platelet, not other cell types. Its main job is a reconnaissance flight. It looks around billions of platelets, looking at the billions of endothelial cells in the inner surface of the artery, or in the vein even could happen. Yes. And if it sees any break here, because we sometimes inadvertently we can cut the tissue and the blood will come out. So then platelet will find out that there is a discontinuity of the bed, endothelium bed on the artery or vein, and then it will aggregate. It will all the platelet not all, most of the platelet will come and rush here, and they will try to seal this place so that no blood can go out. As I mentioned, if we lose the blood, we will die. So it is very important the platelet will come and make a kind of a clot formation along with the other blood coagulation processes, which I'll not go there direct. Then they make a kind of seal, and once the seal is produced, then the tissue is repaired under basement repair, etc., smooth muscle cell, then whole thing will be slapped off, dissolved by fibrinolytic system, and blood flow will start normally. This is called hemostasis. I told you about it many times. So, but if this doesn't happen, platelets should move freely. They should not touch each other, should be active to do the physiological job, but should not be hyperactive to do the unphysiological job. That is the main theme of the Hearty find. So under normal physiological condition, this the artery, if you look at the surface, all these molecules we call von Willebrand factor, collagen, etc., and others, they're buried under the membrane. They don't come out. But when platelet become active because of our lifestyle changes, because of high-fat diet, because of sitting there a long time, sedentary lifestyle, inflammation, oxidative stress itself, and for a lot of other reasons, this platelet become active, and they will then release some of the molecule that will aggravate the membrane of the arterial wall, and this will be expressed. And then you see here, they are expressed on the surface, and they will drag the platelet, and the platelet and other cells, leukocyte, they will bind here, and as you see the aggregated platelet here, that is the beginning of the plaque formation. And that starts when you are young, and it goes on, and ultimately lead to a plaque. The monocyte, macrophage, everything comes embedded here in endothelium, take the fat molecule and make a huge inflammatory reactions, and then they produce kind of a strong plaque, and then ultimately the blood flow is stopped, and then the event can happen. But how can we stop the platelet doing this? That is the question. As we know, the inactive, as we sit long time here, that can give the platelet hyperactivity, smoking, diet, wrong kind of bacteria, stress, high physical activity also can activate the platelet. The sports person, they can do. And so all these things actually changes the platelet behavior. Then they release some of the molecules that actually changes the network, vessel network. So just go to a little bit basic biochemistry, how these platelets are aggregated when it is activated. As you know, the nature actually gives so many pathways platelet to be activated, because without platelet aggregation, as I mentioned, will not survive. So nature makes sure that platelet activates. So it happens in such a way that collagen, when we damage our membrane, vascular the collagen is expressed here. And then collagen can bind the platelet and then activate the platelet. ADP, when the red blood cell is broken, not because of, it could be happen in dengue and other situation, then ADP is released and activate the platelet. Adrenaline, that is a stress hormone. If you get stress, with high blood pressure, adrenaline will be activated and activate the platelet. And the thrombin, generally it is not in the circulation. It is only released when we have a plaque broken. And that is the beginning, end of life. Because it's thrombin, generally it needs an extrinsic pathway to be generated from prothrombin. And when thrombin comes, that will activate the platelet. Also, they will produce the coagulation cascade that I'm not going there to produce the huge protein clot. But without platelet, it cannot do anything. So that's why it also activates the platelet. All these things together or separately can activate the platelet to aggregate the platelet one-to-one each other. But thrombin can activate platelet even if you take aspirin. Is no problem. They can. And they how they do, they actually express the fibrinogen receptor. Fibrinogen is a protein that is a kind of a glue. It binds active platelet through glycoprotein 2B3A. That's why platelet is aggregated. And if somebody is obese or smoking, fibrinogen level is very high, so platelet become more active and more aggregative. But here is important thing that I should tell. There is that any of the aggregating agent, collagen, epinephrine, ADP, what it is ADP here, so it is white, you can't see, but it is ADP. And all these things, what they do, they break the platelet membrane through their receptors, and arachidonic acid, that is a omega-6 fatty acid, that is released from the membrane because by them through phospholipase, and this arachidonic acid then through cyclooxygenase, they produce thromboxane A2. This thromboxane then expresses this protein. But if you take aspirin, then cyclooxygenase is inhibited, so there will be no thromboxane A2 formation. Then you can stop collagen, epinephrine, ADP to some extent, but if thrombin is there, because of the plug broken, it does not care. It can activate the platelet through directly without involving thromboxane A2. So this is a problem. And aspirin cannot do anything with that. So even somebody taking aspirin regularly, those who have a stunt, if the plaque is broken, is a danger. So that means we have to make sure they don't develop plaque even after having a stent or bypass. The further plaque formation should be stopped. But the drug, they take aspirin, of course, because only they can take aspirin, not those who don't have it, can stop to some extent. But I'll be talking about today that Hearty can also do that without having any side effect. But the one important thing I should mention, this arachidonic acid is a omega-6 fatty acid. Its precursor is present in any seed oil. That means peanut oil, sunflower oil, mustard oil, every oil, seed oil, plant seed oil has linoleic acid. And linoleic acid is actually the precursor that produces arachidonic acid. Why in 1960, when people are seeing a lot of people having heart attack and found the cholesterol there in the clot, in the plaque, they thought we should reduce the cholesterol. How can we reduce it? We reduce it by taking less of saturated fat. But you cannot reduce the total energy need. So they replace the saturated fat like palmitic acid, etc., palm oil, by all the seed oil. And that seed oil contains linoleic acid. So now we have a more arachidonic acid than 70 years back. And this arachidonic acid is a precursor of all its icosanoid. And we are producing more of thromboxane, more of icosanoid, more of leukotrienes, and more allergy we have because of more arachidonic acid. We have more tendency to cardiac problem because of thromboxane production. We have more of other problems, psychiatric disorder, because we have plenty of arachidonic acid. One way to counter it, to take more of omega-3 fatty acid, but this is a different story. I will tell you something like that in other day. But the most important thing here, message is that thrombin can aggregate the platelet if even aspirin is taken there. But aspirin effect is not that, universal. It can stop thromboxane A2 synthesis, but when it comes to thrombosis, myocardial infarction, stroke, vascular mortality, or total mortality, it fails. It doesn't have, because every day we produce 10% new platelet, because platelet life is 10 days, so that some platelet will not be aspirated. 30% people are not responding. And more important thing, that when the cardiac event happen, the thrombin is generated, and that thrombin induced platelet aggregation cannot be stopped by aspirin. But yet there are a lot of side effects of if you take aspirin regularly. It gives stomach irritation. If somebody is very sensitive, it can lead to hemorrhage kind of things. Somebody has allergy, Ray's syndrome. And 30% people don't work with it because they are resistant to aspirin. In kidney toxicity and liver toxicity. That's why as I mentioned, the gut will be destroyed. That's why the cardiology of Europe and of FDA or America, they said one should not take aspirin if someone is healthy and someone has no cardiovascular treatment like having a stent or bypass surgery. But what we'll do that we now know that platelet hyperactivity, as we see, people like with insulin resistance, they don't have a diabetic syndrome, anything yet, but they're insulin resistance. That can be anybody, from young kids to old people. Their insulin is not working properly because of membrane is different. They are not very hyper active physically, and their food diet having a lot of saturated fat, etc., that lead to insulin resistance, but it lead to platelet hyperactivity. Of course, diabetes can lead to platelet activity by different mechanism. Smoking can lead to platelet hyperactivity. Sedentary lifestyle, those who don't walk 30 minutes at least per day, they have a big problem. Obesity, and if you get old, of course, platelet become active. And dietary effect, saturated fat, and some has a lot of oils, like we use a lot, trans fat, dalda, etc. That all lead to hyperplatelet activity. Oxidative stress, if somebody taking a less of antioxidant, less of fruits and vegetables, there will be oxidative stress in the body that can lead to platelet hyperactivation. And also hyperlipidemia, like HDL, LDL. HDL is less, LDL is high, total cholesterol is high. We call it, and free fatty acid and triglyceride is very high. These are hyperlipidemic situation, and their platelet is hyperactive. Hypertension, high blood pressure condition. In cancer, most of the cancer people die because of heart attack, not because of cancer, because platelet is so active. And platelet hyperactive means this goes everywhere, and they carry, metastasize the cancer cell. And as we see in the COVID patient, this COVID virus, SARS virus, they can go into the platelet. They use this as a vehicle transport to go anywhere. And they do it, and that's a major problem was in a cytokine storm that we see this. And the pollution, microparticle 2.5 micrometer they can directly activate the platelet. We see in Brazil and Argentina in the pollution like that. A lot of people have a cardiac problem. They have everything okay, but platelet become hyperactive. Microbiota, as I mentioned, the gut microbiota is so important, but we are destroying every day because of 2-3 reasons. One reason is, of course, the pollution, a bad diet, because microbiota needs resistant carbohydrate. We must have 40 grams of carbohydrate, the resistant carbohydrate, fibers in our diet. If it is not there, this microbiota residing in the large intestine, they don't get their food, because most of the simple carbohydrates they're absorbed in the intestine. So nothing much left for this microbiota to survive and work and produce the vitamins, tuning the body, tuning our brain, blood flow, and keeping platelet tame. It is not there because and also a lot of chemicals through medicine, they are getting it and get a big problem. And this is very important issue. And the cesarean babies, they don't get the good microbiota. This is also a problem. So, but this is not the matter today to discuss. And also the stress can lead to that. So, if this condition persists, and most of the people have this condition in India because of living standard, food, high, and they don't understand all the time the physiology, that can lead to platelet hyperactivity. And here, that lead to plaque formation in the coronary circulation mostly. It can happen in other places. And that is it 5-10 years matters. We have to make sure that the brain system is always good. But once it is started, and they will get the cholesterol. Cholesterol doesn't matter whether you normal or high or etc. because the cholesterol is floating in the blood. Platelet will use that, or the atherosclerotic formation will have access to the cholesterol. It can be more if somebody is hypercholesterol, but cholesterol is there. Without cholesterol, we cannot survive. All our membrane, tissue, etc. has tons of cholesterol. and is very important for us. So it is not a problem. They will get it. And if it goes on and on and on, then we have a narrowing of the artery, and it create a problem, like it allows less blood to flow to the heart, which needs a lot of energy to pump blood all over the body. It's a huge work. They need a continuous flow of energy, glucose, carbohydrate, in some case, sometimes amino acid also. And if it is not there, we feel angina, we myocardial infarction there, and also it can happen in the brain. Blood flow is not there, then we have a stroke situation. But how can we stop it here so that we don't have a platelet hyperactivity? We don't have a atherosclerotic formation, so we can avoid this CVD events in the future. And this is to show you this part that happens when the cardiac event happens. Platelet activation gives a lot of the nasty molecules, epinephrine, serotonin, histamine, substance free, that is changing the arrhythmic situation, muscular dysfunctionality. And, oh God. And and the reactive oxygen species, serotonin, histamine, and thromboxane, the vasoconstriction, high blood pressure. Platelet hyperactivity can lead to the hyper. Oof. I don't know what to do. And, I can stop. Okay, anyhow. So this, what I'm saying, yeah. So, and if platelet is hyperactive, that can lead to breakage of plaque and can increase the thrombin formation. So you see, if the platelet hyperactivity is there, they produce these molecules and changes the tuning of the our brain system, and it is much more so in the cardiac, in the heart, and also it does so many things when platelet is involved in a final event. So we make sure that the platelet activation does not happen. It only works if it is needed. That is when the vascular injury is there or anything. Other than time, the platelets should not be involved. Well, how can I do it? But the physical activity that we are doing, the food we are taking, etc., that actually enhances the platelet activation. We don't want it, but it is happening, and the aging. So this is a balance we need to do. And the gut bacteria, if we change our gut bacteria because of bad diet, and if they don't get the proper resistant fibers, etc., then this bacteria will produce TMA, trimethylamine. That will go to the liver and then produce trimethylamine oxide. They will give you diabetes, platelet hyperactivity, abnormal lipid metabolism, obesity. Even if you are taking a normal diet, carbohydrate, fat, etc., but because of the wrong kind of bacteria, that will create a big problem. Although by clinically, your lipid is all right, other thing all right, but bacteria is different. So that is another problem that we need to discuss about it. And I don't want to go details into that, just to tell you that red meat is a source for TMA, and that high meat protein, high meat diet, etc., that will go to the here in the gut, and in the gut certain amino acid then produce the trimethylamine, and this trimethylamine then in the liver to the flavin monooxygenase, they produce trimethylamine oxide. That is the killer. They can produce atherosclerosis with platelet hyperactivity they will produce and create thrombosis. They can have fibrosis in kidney and loss of function and other things. We must think about it. And another thing is platelet vessel interaction. If platelet is hyperactive, then it will, hyperactive, the damaged endothelium system and platelet crosstalk is different. They lead to activation of sympathetic nerves and NPY, and ultimately vasoconstriction and high blood pressure. And this sort of reason behind blood pressure increase cannot be treated by simple taking traditional blood pressure medicine like beta blocker, by angiotensin converting enzyme inhibitor, or calcium channel blocker. It doesn't work. You will find always some people that actually have a high blood pressure, even taking multiple anti-blood pressure medicine. So here we are now. We have a pathologic situation that is we are all the time we are changing our body through different physical activity, unhealthy diet, smoking, hyperlipidemia, pollution, etc., and that lead to platelet hyperactivity. And this platelet hyperactivity lead to cardiovascular events. Oh, so many calls coming today. I don't know. I should be in a vacation. And this one is aspirin. Sorry. And this aspirin, I already told you that it cannot be used for normal, so-called healthy people. But then, what is the choice? Our choice is, diet and dietary supplement. Of course, omega-3 fatty acid, they work to some extent, but you have to take tons and long time because it has to go to platelet membrane to replace arachidonic acid. Then it can reduce the thromboxane. So it is not possible. And as aspirin side effect, I already mentioned that these are the drug is currently being used in combination others, but this is for the patient. But I'm talking billions of people, Indians or worldwide, what they can do. They have a hyperactivity of the platelet. This cannot be used for those people. So, and that time, of course, we know that fruits and vegetable has a beneficial effect, mostly because of antioxidant. But then we discovered that antiplatelet factor also most important in addition to antioxidant, because all the fruits and vegetable has antioxidant, but it doesn't mean their platelets are in a good condition. So they have to consume certain kinds of fruits and vegetable. Here in the case of here, it is kiwi and tomato, not other fruits. So what I did it, how we find the kiwi fruit has that activity. So we made a juice of kiwi fruit and make an extract and or juice, and then we isolate the platelet. We added this kiwi fruit extract and measured their aggregation activity. And we found that if you add kiwi fruit extract or kiwi fruit juice, it can inhibit platelet aggregation induced by ADP, collagen, and arachidonic acid. So this is the beginning of a journey of kiwi fruit that is showing that its extract or juice can inhibit platelet aggregation. And this is a comparison with other fruits. Only it is compared with tomato. It is kiwi fruit is more as effective or more effective than tomato, and other fruits can inhibit to very little extent, like grapefruit 44%, but grapefruit you cannot use because it has a other side effect. If you take medicine, grapefruit is no grapefruit. Melon, plum, banana, they have some activity. Pear doesn't have any activity. So we thought that we should working on the ingredients that is responsible for platelet aggregation inhibition. So we took the kiwi fruit and make an extract, and we use different procedures because of patent reasons and company secret. We cannot share this information, only to show you that if you add kiwi fruit extract at different amount, you can almost inhibit platelet aggregation 100%. This is the control, platelet aggregation, and with the increase of KFE, you can inhibit platelet aggregation in the dose response curve. So this is the very beginning and very happy moment for us, showing that the something aspirin-like effect is there in the kiwi fruit function. Then what we did several trials, at least 7 to 8 human trials. You will find those trials in the published papers, peer-reviewed journals, and also in the patent. Here we used initially, that was in 2004, We have I forgot how many people involved there. They are given 2 kiwifruit to consume for 28 days, or 3 kiwifruits for 28 per day. They have to consume 2 kiwifruits or 3 kiwifruit for 28 days. Then at the beginning, they give the blood. We measured their platelet aggregation. It is 70%. But when they come back after consuming 2 kiwifruit per day, they have only 53%, because we don't want less than 50% platelet. There will be bleeding problem that happened in aspirin. But what we did here, the hyperactivity is reduced, but platelet activity is retained. So this is the idea. And we did not find much difference between 2 kiwifruit and 3 kiwifruit. They are almost same way they did it. And they are working against ADP, against collagen, against in a different concentration, against arachidonic acid, even against thrombin, which aspirin cannot do. And then we measured also plasma lipids at day 0 and day 28. As we know that it does not impact the cholesterol level as such, but it reduced significantly triglyceride from 1.16 to 0.87. So this is very important, millimolar. And that happens in both 2 and 3 kiwifruit. So what we noticed here, what is the message from this clinical trial, that human being consume 2 kiwifruits per day or 3 kiwifruit, after 28 days, they have a less hyperactive platelet, and also they have a reduced triglyceride in their plasma. And these are the 2 important risk factors for cardiovascular disease. So this is the way we prepared, although there are a lot of steps involved in it. But this is a kiwifruit, you probably know, because some people can consume it. And then you see the oil-like structure, the syrup. And then after sugar removal, you see this color, not colorfully, it is a little bit brownish, depends on the source is there. And also we did, again, several studies showing that this is a no kiwifruit extract, aggregation is 100%. And you give different kiwifruit extract as a pure juice, as a pure extract, but in a liquid form, and you can inhibit the platelet aggregation. So then at that time, we are interested whether it decreases the hypertension or not. And we know very well that angiotensin 2 is the major hypertensive agent, and it is angiotensin 1 produced in the kidney, then angiotensin 2 is produced from 1 to 2 by angiotensin converting enzymes. And a lot of medicine like ramipril, etc., they are targeting ACE or ACE receptor like losartan, etc., to maintain the blood pressure. So we're interested the kiwifruit extract that we prepared in a final pure form, does it inhibit angiotensin converting enzymes as we know in the case of ramipril, captopril, etc. And to our surprise, we found this enzyme study that's showing that with a different milligram of kiwifruit extract, and this is the captopril, they both are showing the inhibition of the enzymes. So this is a very good discovery, because captopril is a ramipril. They are derivatives and used as a human blood pressure lowering agents. And kiwifruit extract, very humble source, it can also do the same thing. So then our trial, we did several trials. This is one of the largest trial done in Ireland by a CRO company. And we have a 200, we call it patient because they are a little bit hypertension, moderate, systolic blood pressure between 120 and 140. And they are given a whole fruit and kiwifruit extract also for 8 weeks. And we found they significantly lower both systolic and diastolic blood pressure. And this is the changes we have noticed. If you look here in the control people, there is not much change. But when it comes to, we also use the antioxidant just as a control. Antioxidant, strawberry, blueberry, etc., and give them with the same amount as kiwifruit extract. You see here, the change is 10 millimolar mercury, 10 millimeter mercury changes after taking this kiwifruit extract. Antioxidant does not affect, so is the control. And this is the beginning of the story that we found something very, very novel that actually reduced the diastolic blood pressure, at least 10 millimeter mercury. In addition, they decrease the whole blood aggregation. That we also measure whole blood, not platelet aggregation here. This is very important. It's physiological aggregation, 23%. This is the design it was. And so we are very happy at that time. This study was known to the world, in America especially. A lot of media report about this. And this is the first time showing the kiwifruit is a strong anti-blood pressure agent. In addition, as we discovered before, anti-platelet effect. So a lot of studies done. This is another study. It's published in Journal of Human Hypertension. It is showing that kiwifruit extract versus control is always -12. 100 people involved. This is done in a big hospital in Oslo, Ullevål Hospital. And after 8-week consumption of the kiwifruit extract, we found this is the situation. So then we did several studies, and this is the way we did. We did the initial screening. Then certain groups will go to kiwi extract, others on placebo. Then they have washout period. Then that placebo will go to the kiwi extract, consume the kiwi extract, and other group with placebo. So this is the way they is powered. Another trial that gives you indication whether it decreases the blood pressure or not. And 67.5 milligram, that time microgram it should be, was used for the study. And these are smokers, most of this. And these are their normal, their anthropometrics. They are 31 to 74 years old. And they have this blood pressure, BMI is very high. And all of them actually responded when it comes to kiwifruit extract, high blood pressure, etc. As you see, within even 6 hours, within even 6 hours, we can see actually 3 hours, we can see 11 millimeter of mercury and then 7 millimeter mercury. And it goes on. And after 24 hours, it vanishes. So that means you have to consume kiwifruit extract every 24 hours in order to maintain the low blood pressure. So here we are now. We have an extract, novel extract, that from kiwifruit that can inhibit the platelet hyperactivity so that they can inhibit atherosclerotic situation, and that can inhibit the future event of cardiovascular event. At the same time, those are hypertensive people, their blood pressure will be normalized if they take the. So there are two-prong attack, the two important risk factors in the cardiovascular event. Plus it increases the blood flow. Blood flow increase means you will feel less cold, your skin will be much better, your brain will be much more active because it maintains. And if somebody has stent or bypass, etc., they will not go for another plaque formation, etc. If they take Hearty, it stops them to maintain. And also it decreases the triglyceride level. So here we can say that kiwifruit extract has a potent antiplatelet, antihypertensive factors. And I did not go to the details of how we make it because of patent and other restrictions. It is a water-soluble, heat-stable, and very low molecular weight, 1,000 Dalton. And it has no allergy, nothing else, everything there. It can be easily absorbed within 2 hours. You can see the blood pressure easily changes and platelet activity. And it can mix with any kind of matrix, from curry to what do you call it, tea bag, etc., because it's heat stable. It decreases blood pressure. Even in the healthy people, it maintain that. So we call it the most cardioprotective function with evidence in this century. We have a lot of publications and patents with this is there. And with this Hearty, we also mix L-arginine. Arginine itself can produce nitric oxide. It can tune the endotheliums, so it can increase the vascularity of the blood vessel network, and also it decreases the blood pressure. And in diabetes also, if somebody has an insulin resistance, it can also help them. So today we are here. We have a Hearty that is contain the kiwifruit extract, which is proven scientifically, both in the cell lab, in human body and clinical trial. And L-arginine also mixed together, that gives you Hearty, and that is the thing is today for you to take it to the people. Thank you very much.